All right, so basics. What I want to do is just kind of review what we do for um, fractions, because your basic rules for fractions still apply for doing rationals. And a lot of times that's the problem, is people don't think of these as their normal fractions. So, whenever I have something like 6/8 and you're asked to reduce that, what's that reduced to? 3/4. So you guys can do that fairly quickly. What you need to make sure you know is the steps you use to reduce that, because those steps are what we're going to use to reduce this. What you actually do is you're factoring this, and then you look at that and you say, okay, what do those have in common? Well, both of those have a 2, so I'm taking that 2 out. So the one I'm left with is a 3 on top and a 4 on the bottom. So when we first learned, that's how you learned how to reduce fractions. But then you get really good at it and you stop thinking about it. You just do it. So same thing with multiplication. Now, before we multiply those together, we can actually reduce before we multiply, right? Yeah, the 3 and the 6 will reduce. So the 3 would become a 1, and the 6 would become a 2. And then when we multiply fractions, we just multiply straight across, right? So 2 times 2 would be 4. 1 times 5 would become 5. Come on, you're fine. All right, so that's what we have for multiplication. Division. If I did division, if I did that for division, what do you have to do before you can divide fractions? So we change it into multiplication and do the reciprocal. Okay, then we have a lot of stuff we can cancel out on this, right? So what's my final answer? Okay, how about how do we do that? 6/4. When we add, we just add across the top, right? Just add numerators. Okay, and if our denominators are not the same, what do we have to do? Get like denominators. We have to get our denominators the same. So in this case, I would need to multiply this one by 5/5, multiply this one by 2 over 2. So I make this 15 tenths minus 2 tenths. And then we reduce if we can, which in that case we can't. So I just wanted to review those steps because that's what we're doing today. We're just doing it with x's involved. The only extra step we have in what we're doing today is we have to add in factoring. But beyond that, it's the same exact thing. Okay, so let's start off with simplifying. Okay, like I said, as I go through this, I'm going to review your different forms of factoring. Some of these might be more of a review than others are. Okay, so for this one, this bottom, before I can simplify, I have to factor. All I can do with this is pull out greatest common factor. So both those numbers have an 8 in common. Variable-wise, I can pull out an x squared. So if I divide this by 8x squared, I'm left with a 1. If I divide this by 8x squared, I'm left with an x. Now, if I go too fast on anything, tell me. 2x, sorry. If I go too fast and mess up, tell me. Okay, before you do any canceling, things have to be separated by multiplication. If they're not separated by multiplication, you cannot cancel it. So anything inside of here is stuck. The only way I can cancel anything in here is if I have the exact same thing up here. So I can't cancel this unless I actually have a 1 plus 2x up here. So I cannot select, this 2 to cancel with the 24. I can't do that. That's the biggest mistake most people make. So this plus locks this thing together. I can't cancel it unless I can cancel the entire piece. Alright, but I can cancel the 8 and the 24 because they're separated by multiplication. Same with the x and the x squared. Separated by multiplication. So I can cancel that, so I'm just left with a single x. So I'm left with 3x over 1 plus 2x. Again, I cannot cancel these x's because this x is tied together with a plus sign. Alright, you good on that one? Again, I always worry I'm going too fast. So if I do and you miss something, or just tell me. Okay, numerator is difference of squares. You can tell difference of squares because you have a minus sign. First number, last number are squares. If it has a plus sign, it is not factorable. Alright. So, difference of squares says I take each thing write what they were before they were squared. One has a plus, one has a minus. If you forget that rule, you can fall back to the same way we factor this. Just put a 0x in the middle. A trinomial with no number in front, which none of them that you're going to be doing today have a number in front. When we get to where we need to do the ones with the number in front, I will cover that. But whenever they don't have a number in front, we can use a shortcut. We need to find two numbers that multiply to be the last number and add to be the middle number. So in this case, that would be 5 and 1. Now, the shortcut says as long as there's a 1 in front of that x squared, these are my answers. So I have an x plus 5 and an x plus 1. Yeah, if there's a number in front of the x squared, then you have to go through the entire process. The entire process is different depending on who your teacher was. I mean, it's the same, it just looks different. Some teachers teach this box method, some teachers just, I mean, it depends on your teacher. Yeah, I don't like the box. Okay. These two, I mean, things are tied together with the addition and subtraction, so in order to cross them out, you have to be able to cross out the whole thing. So I can cross out this whole thing with this whole thing. So then my answer is x, oops, that's not an x. X minus 5 over x plus 1. I cannot cross anything else out. Now, I can prove that to you if you want. If you're confused by that, I can prove it to you. Because if I cross out those x's, that would tell me my answer is -5, right? Okay, put a number in for those x's. If I put in a 3 for those x's, that would tell me my answer is -2 over 4. -2 over 4 is not equal to -5. So that right there tells you that you cannot eliminate those x's because it will give you the wrong answer. Alright, you okay with that? So, you okay with those two types of factoring? Okay. Last two types of factoring you're responsible for at this point are those two. Okay, top one is sum and difference of cubes. The rule is really the same no matter whether you have a plus or minus sign. The only difference is where you put a plus or minus sign. So let me write out the rule for the sum of cubes, then I'll show you the change if you have a difference of cubes. Okay, so the rule for sum of cubes. Okay, that's your rule for sum of cubes. Now, that second part, I don't believe that second part is ever factorable. You might be able to find some weird, messed up case where it might be factorable, but I don't believe from 99% of the cases that second part is ever factorable. Okay, for difference of cubes, if I put a minus sign in here, all that changes is this becomes a minus sign and this becomes a plus sign. Now, what I usually tell people is just memorize the sum of cubes and then just put a negative sign with the b for difference of cubes. Just treat b like a negative. So that would put a negative here, which would change this sign. That would put a negative here, which would change this sign. And this sign wouldn't change because whenever you square the negative, it still becomes a positive. That way you only have to memorize one rule. Yeah. Yeah. If you don't like doing that and you prefer to have 2 rules, do 2 rules. I don't care. So using that rule, what I have up there would become, so the x plus, and then to get 27, I would cube 3. Then I would have x squared minus 3x plus 9. So it's kind of like difference of cubes. You just have a formula to plug it into. You just have to know your formula. Again, hopefully that was presented to you in Algebra 2. Hopefully this is the second time you've seen that. It's not something I'm expecting that you know, because I believe that you shouldn't know something until at least the 3rd time you've seen it in a class. So at this point, I'm thinking that this should be a reminder to you and a reteaching to you. That's why I'm kind of stopping and slowing down with that one a lot. I'm just really hoping it's not the first time you've seen it. Okay, with the x4, 3x cubed plus, that one is factoring by grouping. So what you do is you simply group them into 2s, because really you can't, besides greatest common factor, you can't factor anything with more than 2 terms. Even our 3-term thing, what we do is technically we split the middle term into 2 terms so we can factor by grouping. So we take out of here, let's see, they both have an x cubed in common. These two have a 5 in common. So then we have x cubed plus 5, x plus 3, and that one's factored. If I wanted to be really mean to you, I would have made this a nice cube also, so you would have had to use cube again, but I figured I was mean enough already. Alright, so the numerator is x plus 3. X squared minus 3x plus 9. Denominator is x cubed plus 5, x plus 3. So my x plus 3's cancel out. There you go. Okay, so that's simplifying. Alright, now we're going to go a little bit faster now that we've done simplifying. We'll slow down a little bit more when we get to addition and subtraction, but multiplication and division are really just simplifying. Because multiplication, really all you're doing, you multiply across the top and the bottom, right? So I could rewrite this like this. But after we multiply, our next step is to simplify. So I don't really want to multiply these out because in order to simplify, I'm going to want to factor. Well, so after I multiply them, I'm going to want to split them back apart. So why multiply them? So what I really want to do is I want to factor everything and see what I can cross out. So multiplication is really just another exercise in simplifying. So let's see. Up here, this one, I can just factor out an x. X squared minus 1, that's difference of squares. This is a trinomial, so what are two numbers that multiply to negative 4 and add to 3? Okay, 4 and negative 1. Okay, then after we have it all the way factored, we just go through and see what we can cross out. So I can cross out an x. I can cross out this x even though it's with a 2 because, again, this is separated by multiplication and there's no addition inside these parentheses. So that is okay. Cross out my x minus 1. Nothing else can be crossed out. Now, your book goes ahead and multiplies things out. I do not care that you multiply things out. You can leave them factored. The reason is, a lot of times in math, whatever you're doing this for, whenever you move on, you're going to want them factored anyway. Because most of the time, wherever you're going to go and use these again, you're going to want them factored so you can see if you can cross more stuff out. So a lot of times there's no reason to multiply them together. If you need them multiplied together, then you can multiply them together later. So I am totally okay with you leaving things factored. There's no reason to do the extra step of multiplying. Just realize if you look in the back, most likely they're going to be multiplied together. All right, am I going to switch? All right, division. First step is that we change division into multiplication. And then we factor. Because again, multiplication is just a chance to reduce. The x squared minus 9 is just difference of squares. X cubed plus 1 is sum of cubes. I left it like this so you, again, this is the same as what we were doing on the very first page. We can actually reduce before we multiply. Just like what we were doing with before we even put x's in there. Just one. That's why, and I have lots of people who put zeros and stuff. That's why I did this one here. Remember, when everything cancels out, you're still left with a 1. It's not a 0. Because if I put a 0 up there, that would turn this whole problem into 0. Whenever we have a number over a number and they cancel each other out, they turn into 1. Okay, addition, subtraction. First one's quick and easy. Like denominators, what do? Add across the top. So what's the answer to this one? X plus 1 over x plus 4. So I add across the top. So I take the 3 plus the negative 2. Add my like terms. So that's all you have to do with that one. That one is done. So you add your like terms. Nothing I can add to the x. The 3 and the negative 2 get added together, they turn into 1. Because I have like denominators, so all I have to do is add the numerators.
Nothing.
All right, we good for the next one? All right, 2 more. They're longer, but just 2 more. All right, so this is where we start getting into some work, where we don't have like denominators. Okay, so before we can do anything, we have to get like denominators. Now, if you just try to multiply each fraction by what's on the other fraction's denominator, you're going to end up with a huge mess. That will be even a larger problem to try to clean up and reduce. So what we want to do is we want to find our lowest common denominator. So to start off with, your first step, what you want to do first is you want to factor your denominators. So if you're the type who likes to have steps to follow, that's your first step. Okay, they both have an x minus 2. So, if I want a lowest common denominator, neither of them need that x minus 2. They already have it. So, this denominator, what does this denominator need? An x plus 5. So, what I need to do is I need to multiply this one by x plus 5. That's what this one needs. If I put an x plus 5 in the denominator, what do I need in the numerator? X plus 5. So it's the same thing on that first problem. We multiplied by 5 over 5. Same sort of thing right here. This one is missing an x plus 2, so I give it an x plus 2. But whenever I give it an x plus 2 in the denominator, I have to do the same thing to the numerator. That's how you get your like denominators. So then the rest of it is just working through the problem. Now, the denominator, you do not have to multiply the denominator out. In fact, it is a waste of your time to multiply it out, because in order to see if you can reduce at the end, you're going to have to refactor it. Now, a lot of times what I do is I get tired of writing that over and over again. So what I start doing is I start saying, this denominator here is equal to squiggle. You can substitute things in math, right? A lot of times, especially in calculus, you start substituting. You'll take something long like this, you'll say that's equal to u. And you'll start substituting it in. I don't like using letters. I like using squiggles. So I'll just start putting my denominator as a squiggle. It saves me from writing a lot over and over and over and over again. So there's the tricks of Mr. Collette. Okay, so now after I multiplied out my numerators, I can subtract them across. See, I left out one of the places where I could write squiggle, because now in my next line I'm going to have to actually write out the denominator. So 2x minus 7x is negative 5x. 10 minus 14 is negative 4. You just always have to make sure that whenever you get to your answer, you write it out. Oh my goodness. Whoever is emailing is freaking insane. It is driving me crazy. Okay, now we have to see if we can reduce. This is not factorable. The only thing I could take out is negative 1. And I have nothing that matches that in the denominator, so I am done. That is my answer. But if you have long problems where you have to take something like this and write it over and over in your denominator, feel free to substitute it with something else. If you don't like the idea of using a squiggle, use another variable. I mean, a lot of times in calculus, that's what you're going to end up doing anyway. I just, letters are conformist. Who likes conforming to the norm? That's why I use smiley faces. Okay, sorry, I took that away without asking. Everyone got that? Okay, complex fractions, last thing. Now that we've taken over a half an hour for notes. Okay, start off with viewing this as two separate problems. View this as a problem in the numerator and a problem in the denominator. If you're lucky, one of them won't be a problem. But just to get you used to seeing this, first step, look at your numerator. Well, that's simplified, so I can be done with that. Second step, look at your denominator. The problem is a lot of people get overwhelmed because they try to look at it at once, and they try to simplify it by simplifying it as an entire thing. Don't do that, because you will get overwhelmed, you will get lost, or you will make mistakes. Look at it as pieces. Okay, this can be simplified. I need to get like denominators. Now, also realize whenever I tell you to don't do something, you can do whatever you want to do. As long as you get the right answer, I'm happy. If you decide to take this whole thing and do it, and I see you do that on the test, I am not counting you off anything. Okay, so I distribute that 3x plus 6 over x squared plus 2x. And see, I just did what I told you not to do. I don't know why I did that. I got too excited there. I shouldn't have multiplied that out. Okay, add those together. So 4x plus 6 over